So come back to CBC 2 program, and today we will be discussing DPP 13, I think. So hope everybody have solved this DPP, right? So yesterday evening also some of the students have clarified their doubts through WhatsApp. So I felt it very happy that the students even in your summer vacation also are utilizing it properly, right? So other students also, so be in preparation, right? Whatever the concepts we are discussing, you have to clarify all that concepts before you enter into the main program, because these are the fundamental concepts which will be needed. The student who knows this concept and those who do not know this concept, there will be definitely difference in the pace in absorption or in understanding the complex concepts what the faculty will be explaining in your main course, right now. So every day your cycle is same. So first whatever concept is explained, that you have to revise. You should take the notes, then revise it, and then do the DPP, and then in the next day you have to ask your doubts and clarify your doubts. Not only I am available through WhatsApp, but also our faculty, whoever are you have particularly joined in one campus, right? Suppose you are joined in Madhapur campus, Chola campus, Dundigal campus, or whatever, like as an example I am saying. So in that campus, a dedicated set of faculty will be available from 2 to 5 evening. Every day afternoon session, the faculty will be available. One full set of faculty will be available only to help you only. So those students who are nearby, who can approach, right? So straight away you can go along with your material and can sit with the faculty and discuss all your doubts and can get clarified, feel comfortable and confident when you come for the main program, right? So hoping that your preparation is going well. Even in this summer vacation also, some amount of time you are dedicating to your career, so that is a very appreciable factor for you children. So very good for that. And let's get into the topic, DPP 13 discussion, right now. So first question, which of the following properties of an element is not variable? Not variable. What does it mean, not variable? Means variable means it will change. Not variable means it will not change, right now. So which will remain constant. Not changing means to remain constant or fixed, right, in certain value, specific value. Valency will be changing. Valency is the number of electrons it will participate during the reaction or during the formation of any compound. Suppose if I take iron in some compound formation, it will be losing 2 electrons to form Fe2 plus. Suppose as an example FeO, ferrous oxide, and in some other cases it will be losing 3 electrons and forms Fe3 plus, like you can see FeCl3, Fe2O3, ferric oxide, etc. Right? So depending upon the need, what type of compound it need to be formed, it will be losing different number of electrons, right? So that is what change in valency. Valency is not fixed, it will be variable. So this is wrong. Atomic weight also will be changing depending upon atomic weight is the one which will be remaining constant. Equivalent weight will be changing. Right? So why equivalent weight will change is, whatever the, again, equivalent weight is actually atomic weight by n factor. Atomic weight by n factor. What is this n factor? N factor is what? That number of electrons lost or gained during a reaction. So if the number of electrons lost are different in different reactions, then n factor will be different. If n factor is different, then equivalent weight also will come different, because atomic weight remains constant. So equivalent weight also will be variable. The one which is not variable will be constant is atomic weight. Understanding the point, na? Now, going to the next question. The units of molecular mass or molecular weight is molecular mass or molecular weight. If it is a relative molecular mass, suppose as an example, I will tell you, say, for carbon dioxide molecule. Okay, na? For carbon dioxide molecule, molecular weight or relative molecular weight is 44. What does it mean? Relative molecular weight of carbon dioxide is 44 means what? It means that one carbon dioxide molecule is 44 times heavier than 1 by 12th part of C12 atom. So there will be no units, nothing. Only the number will be there. Only number will be there. Okay. And coming to molecular mass or molecular weight. Molecular mass or molecular weight is 44 AMU. 44 AMU. So here the unit is AMU. Then if you come to gram molecular mass, it is 44 grams. It is 44 grams. So in this manner here the units are grams. So what is asked to you, accordingly you can tick mark it. So AMU is actually correct. He is asking molecular mass or molecular weight. So AMU can be the answer. This is some typing mistake, something is there, kg or something might be there. So that is wrong. Grams is wrong. None of this is also wrong because AMU answer is there. Right now. So for this question, I think there is a key mistake here that it is given as D. To what I have gone through, it is given as D. But answer is A. None of these is not the answer. AMU is the answer. So correct it in your material also. Okay, na? So then 1 AMU, next question. 1 AMU is equal to 1 AMU is 1 by 12th part of C12 mass or 1th part of H1 mass or 1 by 16th part of O16 mass or 1 AMU or 1.66 into 10 to the power of minus 24 grams. In any manner you write, that all will be same. Sorry, 1 AMU is already given. Then we'll take 1.66 into 10 to the power of minus 27 kg. Right now? So all these are the one matching 1 AMU. Now let's get back here. So 1 AMU is equal to the mass of 1 by 12th of C12 atom. Perfect. 1 by 14th of O16. Wrong. 1 gram of H2. Wrong. 1.66 into 10 to the power of minus 23. It is minus 27. Right? So this is also wrong. Only option A is matching perfectly. Okay, na? So going to the next question. The atomic weight of an element is X. The atomic weight of an element is X. Weight of one atom of an element is. Atomic weight is. Atomic weight is X. X AMU actually it should be. Then weight of one atom of that element is. That itself is X AMU, because atomic weight, what is atomic weight means? Atomic weight or atomic mass is mass of one atom, right? So that is X AMU. This itself should be the answer. Or else if you want, according to the options given, it can be X into 1.66 into 10 to the power of minus 27 kg or X into 1.66 into 10 to the power of minus 24 kg. So in this manner you can get this one, right? So x AMU, this is perfect. X into 1.66 into 10 to the power of minus 24 grams, this is also perfect. Grams, this one. Then 1.66 into 10 to the power of minus 27 kg, this is also perfect, and all of them A, B, C, all three are correct. Therefore, answer is all, right? Option D. Then coming to fifth question, mass of one atom of an unknown element. Mass of, here also I think some key mistake is here. So carefully listen to this question. Mass of one atom. Mass of one atom is 4 into 1.66 into 10 to the power of minus 24 grams. This can be nothing but 4 AMU. So atomic mass is 4 AMU. So there is some unknown element whose one single atom is weighing about 4 AMU or 4 times to the 1 by 12th part of C12 atom. So who is that element which will weigh 4 times? 4 times, right? 4 AMU, right? So hydrogen. Suppose you take a hydrogen, even you take a element also, hydrogen will exist as H2 molecule. Therefore, each hydrogen will be weighing 1 AMU. So 2 hydrogens together, 2 AMU it is. Then helium atom. Helium will exist. Noble gas or inert gases will not be existing in combined state. They will not exist as a clusters or molecules. Molecule is nothing but group of atoms together existing, right? So noble gases or inert gases do not exist in the form of clusters or molecules. They will exist in a independent, individual, single atoms. The reason is that noble gases valence shell electronic configuration is already filled. NS2 NP6 configuration is there, right? So therefore, there will be no need of this element to bond with other atoms, right? Because either sharing of electrons, losing of electrons or gaining of electrons, what is the purpose? Is to reach the nearest noble gas configuration. And already this itself is a noble gas. Then what is the need in participation or in bond formation? That is the reason why noble gases or inert gases are the least reactive elements. Very low in reactivity, very high in stability. Therefore, they exist as independent individual atoms, single atoms, separate atoms. So, helium atom will be having in its nucleus 2 protons plus 2 neutrons. These are the nucleons, right? I already told you this point. Atomic mass, right, can be equal to number of nucleons present in it. So the nucleons are present are 2 plus 2 in the nucleus. 2 protons, 2 neutrons together 4. So therefore it can be 4 AMU. Helium will be having the atomic mass 4 AMU. In the question also it is like that only, right? Mass of one atom of an unknown element is 4 into 1.66 into 10 to the power of minus 24 grams. Then oxygen. Oxygen atom, as an atom it is 16 AMU, but directly if it is asked, it will be existing as O2 molecule 32 AMU. Even if it is single atom also, it will be 16 AMU. So in any manner, it will be wrong. Even here also, if he is talking about a hydrogen atom, then it will be 1 AMU, because a hydrogen atom will have only 1 proton. There will be no neutron. Everybody knows this point, right? In periodic table we have discussed. In the nucleus of a hydrogen atom, only 1 proton will be there. There will be no other nucleons. There will be no neutrons. 1 proton inside the nucleus and 1 electron outside the nucleus. That's it, right? So coming to sulfur, sulfur has single atoms if you consider 32 AMU. Oxygen atom AMU is 16 AMU. Sulfur atom AMU is 32 AMU, right? So here the matching answer for AMU 4 into this value, na? So this is a 4 AMU. So 4 AMU. This is matching to helium. I think in your question it is given as a hydrogen, right? To what I remember. So but hydrogen is wrong. It is a helium atom. Next, coming to number of atoms present in a molecule is called its atomicity. Number of atoms present in a molecule is called atomicity. Maybe some of you might not know this concept, atomicity. Total number of atoms in one molecule. Total number of atoms in one molecule, right? So if it is a H2, O2, CO2, O3, SO2, SO3, then S8, then P4, then CH4, C2H6, C6H6 benzene, etc. What is the atomicity of H2 molecule? 2, because the two atoms are clubbing together and forming one molecule. Here also atomicity is 2. Here 1 carbon and 2 oxygens together, all atoms together. It is not a type of element. Type of elements are 2 only, carbon and oxygen. But 1 carbon and 2 oxygens are there. 1 plus 2, it is total 3 atoms are there. Atomicity is 3. Ozone also atomicity is 3. Sulfur 1 plus 2. Here also atomicity is 3. 1 plus 3 atomicity is 4. 1 sulfur with 3 oxygen atoms. Sulfur dioxide, sulfur trioxide, right? S8 puckered or crown structure it will be having, S8 molecule, right? So it is something like this it will be there. Here 1 sulfur, 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 sulfur and sulfur. So you can see here how many are there? 1, 2, 3, 4, 5, 6, 7, 8. So this is what S8 molecule, right? So atomicity is 8. P4 molecule atomicity is 4. CH4 molecule 1 plus 4 atomicity is 5. Ethane molecule C2H6 2 plus 6 atomicity is 8. Benzene molecule C6H6, benzene a very well known organic compound, right? Aromatic compound, 6 plus 6 12, atomicity is 12. So in this manner you can calculate atomicity. Now coming back to this example, or sorry, the same examples are covered here itself. That is, he is asking atomicity of phosphorus and sulfur. Phosphorus exists as tetraatomic molecule, P4, tetraatomic molecule, right? And P4 molecule structure also you can see here. This is a P4 molecule structure, right? So tetraatomic, P4 exists as a tetraatomic molecule, and sulfur exists as octaatomic molecule, 8. So 4 and 8, right? So this is one very common question. Maybe you do not know right now at this moment, but when you go into different chapters, right, these all points will be coming very frequently. But only when you show your concentration, then only this type of points can be catched. Then find the number of gram molecules present in the following. So here one point we have to study here, gram molecule. I hope most of you are not aware of this term, because we have not discussed the gram molecule in the previous classes, yesterday or day before yesterday. Gram molecule is nothing but we have heard of gram molecular mass. Gram molecular mass we have heard. What is this gram molecular mass? Mass of 1 mole of molecules. Mass of 1 mole of molecules. 1 mole of molecules. Mass of 1 mole of molecules is gram molecular mass. Now, what is gram molecule? Is 1 mole of molecules itself is called as gram molecule. Understanding enough? 1 mole of molecules itself is called as gram molecules. In the similar way, can you guess what is gram atom? Gram atom, 1 mole of atoms, right? One mole of atoms is gram atoms. 1 mole of molecules is gram molecules. Gram ions is also there. 1 mole of ions, that particular ions, sodium ions, Na plus ions, sulfide ions, S2 minus ions, like whatever ions are there, right? So, find the number of gram molecules present in the following. Nothing but he is asking moles only. Moles only he is asking. Moles of molecules. Understanding? How many moles of that molecules are present is what he is asking. Now, I will erase this now. But this gram atom or gram molecule, you have to remember this one. You have to note in your notes also. Okay. So, this is a 1 mole of molecules, gram molecule, or else let us take it like this. Here I will write the other part. Okay, na? 1 mole of atoms is gram atom. Okay. So, now 5 grams of, I think it is a neon. Okay, na? So, 5 grams of neon, or else 5 grams of neon. First of all, neon do not exist in a molecular state. It exists already. I have discussed in the previous question that all the inert gases will be existing in individual atoms, right? Na? So, 5 grams of neon. First of all, number of gram molecules or moles is equal to mass by gram molecular mass, right? Na? So, first one, number of moles is what is the mass given? 5 divided by what is its a gram molecular mass. Actually, gram molecular mass writing is wrong because this exists in the form of atoms, right? So, this is a neon, atoms only, that neon gram atomic mass is 20. Gram atomic mass of neon is 20. So, 5 by 20, that is 0.25 moles or gram atoms. Moles or gram atoms. Understanding, you know? Moles or gram atoms. Second one is 7 grams of nitrogen. But nitrogen will exist in the form of N2 gas only, N2 molecules only, right? So, this can be calculated, that is 7 divided by each nitrogen atomic mass is 14. So, 14 plus 14, that is 28. So, 7 divided by 28, this is also 0.25 moles or gram molecules, because it is existing in the form of molecules, N2 molecules. Then third one, no third one, only 2 are given here, right? So, let us match this one. First one is a 0.25, second one is also 0.25. If it is taken like that, you see, here it is not matching, here also it is not matching, here also it is not matching. Only option A is matching, but option A is also wrong here. The reason I told you, if option A has to be considered, then question is wrong. Why? What is the reason? When you are considering it as gram molecules, they should exist in molecules, right? Neon does not exist in the form of molecules here. So, neon exists in atomic state. So, that becomes a mistake here. Or else, what is better is you can write, the question can be corrected in this manner. Find the number of gram atoms or gram molecules. Gram atoms or gram molecules present in the following. If you say gram atoms or gram molecules, then respectively, whichever element is existing, accordingly, we can calculate whether it is a gram atom, if it is existing in atomic state like a neon, and a gram molecule if it is existing in a molecular state like a dinitrogen, N2. Okay, na? So, as of now, just with blindly, if you do the solution, then A is the answer we are getting. What is the mass of carbon dioxide molecule? What is the mass of carbon dioxide molecule? Carbon dioxide molecule mass of CO2 molecule. He is asking nothing but molecular mass of CO2. Molecular mass of CO2 is a sum of atomic masses of all atoms in CO2 molecule. So, what is the atomic mass of carbon atom? There is one carbon atom, two oxygen atoms, right? So, carbon atom atomic mass is 12 AMU plus first oxygen atomic mass is 16 AMU plus one more oxygen is there, its atomic mass is also 16 AMU. Altogether it becomes 12 plus 16 plus 16, 32 plus 12, that is a 44 AMU. 44 AMU is the molecular mass of carbon dioxide molecule. 44 grams is the GMM, gram molecular mass, right? 44 AMU, 44 gram kgs, milligrams, all are wrong. Then the mass of one atom of an element is 40 into 1.66 into 10 to the power of minus 24 grams. The number of protons in its molecule is mass of one atom. Mass of one atom is 40 into 1.66 into 10 to the power of minus 24 grams. This is nothing but 40 AMU, and relative atomic mass RAM is just 40, right now. So, RAM is 40 is what it can be, its mass number also, and this mass number is a sum of protons plus neutrons together, right? Protons plus neutrons together. And generally when it is in even number, generally when it is in even number, it is half and half. Protons will be 20 here and a neutron also will be 20 here, because this is the element calcium he is talking about. 40 is the atomic mass or mass number of calcium. So, 20 protons are there and 20 neutrons are there. Suppose sometimes mass number or atomic mass will be in odd number, like 23 for sodium. For sodium, mass number is, or atomic mass is 23. Here the 23 is for 11 protons and 12 neutrons. So, here they are unequal, right now. So, when they are in odd number, one neutron will be excess over the protons. Whereas, if they are in even number, in general, half and half will be there. So, 20 protons and 20 neutrons here. What is he asking? Number of protons. So, 5 wrong, 10 wrong, 20 correct. Number of nucleons are 40, but number of protons are 20 only, right? Hope you have understood this question also. Now, going into next question, right? So next question, the approximate number of electrons that are required to make one smallest unit of mass is. What is the smallest unit of mass? Is smallest unit of mass is 1 AMU. Smallest unit of mass is 1 AMU. This 1 AMU is nothing but 1.66 into 10 to the power of minus 24 grams. Right? Now, this is the mass of proton or mass of neutron. Actually, this is not required. In the basics of atomic structure, this data is discussed also. Let us not get into this one. Simply, this is the smallest unit of mass. 1 AMU itself is the smallest unit of mass. Now, electron mass, you have to make it into this one. In these many grams, how many electrons are required to make this smallest unit of mass? How many electrons are required in making this 1 AMU? Because electron mass is much lesser than 1 AMU, right? Electron mass is 0.00054 AMU, right? Then how many electrons on making up, on considering, will make it into 1 AMU is what they are asking, right? One electron weighs 0.00054 AMU, or you can write in a reverse, so just for better understanding purpose. 0.00054 AMU is the mass of one electron. Then 1 AMU is the mass of how many electrons? How many electrons? Right? This is the cross multiplication. 1 divided 1 into 1, right? 1 into 1 divided by 0.00054, right? So this can be considered as a 1 by 54 into 10 to the power of minus 5. So if this 10 to the power of minus 5 is taken up, this will be 10 to the power of 5 by 54. 10 to the power of 5 by 54. Okay. So this you can or else you see, I will write it in simplification to match with the answer. I will take it as a 10 to the power of 2 into 10 to the power of 3 by 54. 10 to the power of 2 is 100 into 10 to the power of 3 divided by 54. So closely 54 and 100. This can be of 2 times, 2 times roughly. So this is, but actually lesser, right? So it will be lesser than 2. Okay. So here it is coming to 2000. So the value should be lesser than 2000. So number of electrons should be lesser than 2000. So this is not the answer. This is not the answer. This can be the answer. More than 2000, that also cannot be the answer, right? So if you do the perfect calculation, 100 by 54, how much you will get? Then you will come to here 1.8, 1.85, 1.85 into 1000. That becomes 1852 electrons. So if you collect 1852 electrons altogether and make it into one cluster, that makes 1 AMU mass. That makes one smallest unit of mass, that is 1 AMU. Understanding this point? Then going to the next question. Mass of one molecule of a compound is 1.66 into 10 to the power of minus 22 grams. One molecule mass is this much. Then the molecular weight of the compound is. This is a mass divided by AMU, right? That is 1.66 into 10 to the power of minus 24 grams. This will go, and here 10 to the power of 2 will come up. So that is 100. This is a mass of one molecule of a compound. One molecule is weighing these many grams, right? Then mass of one molecule divided by AMU mass. You will be getting how many times one molecule is heavier than the 1 by 12th part of C12 atom, that is 100 times, right? So this is 100. Then going to next question. The weight of ammonia molecule in grams is, weight of ammonia molecule in grams is, gram molecular mass of ammonia, gram molecular mass of ammonia is 17 grams. This is the mass of NH3. Okay, na? So gram molecular mass of ammonia is 17 grams. But what is he asking? Mass of weight of one molecule only, single molecule he is asking, not the entire total molecules. He is asking the mass of single molecule. But this is the mass of Avogadro number of molecules, right? This is the mass of Avogadro number of molecules. So you can write in another way, that is 6 into 10 to the power of 23 molecules weigh 17 grams. Then one molecule will weigh how many grams? One molecule will weigh how many grams? That is 1 into 17 divided by 6 into 10 to the power of 23. And we know that as 1 by 6 into 10 to the power of 23 is equal to 1.66 into 10 to the power of minus 24. So I will make this one, I will write this one as I will write this one as 1 by 6 into 10 to the power of 23. I will write as 1.66 into 10 to the power of minus 24 into 17. This many grams. These many grams it will be. So is it there? He also has given in the similar way. He also did not do the full calculation. So he gave in the similar manner. So just you can find out here. So this is not the answer. This is not the answer. 17 into 1.66 into 10 to the power of minus 24 in grams. This will be the answer. He is asking also in grams only. Therefore, this answer. Suppose if he is asking in kgs, then D will become the answer, because 10 to the power of minus 27 kgs. So in grams he is asking. Therefore, option C will be matching best. So going to the 13th question, this is the DPP having maximum number of numericals here, right? So it will definitely take time, but it is that you have to follow, understand each and every question perfectly. Okay. Next, the ratio of weights of hydrogen and helium is, ratio of weights of hydrogen and helium is 1:2. Find the ratio of a number of gram atoms. Okay. mass of hydrogen is 1 gram, let us assume, then mass of helium is 2 gram, right? He is asking ratio of number of gram atoms. I already told you gram atoms means moles only, moles of atoms. So he is asking nothing but moles only, right? 1 gram of hydrogen atoms, 1 gram of hydrogen atoms. It is here, mass of hydrogen is 1 gram. So it will be, what is the GAM of hydrogen? 1 gram, right? So 1 gram is already there. It means that 1 mole of hydrogen atoms are there. 1 mole of hydrogen atoms are there. And what is the GAM of helium? That is 4, right? 4 grams. So if it is 4 grams, but 4 grams means 1 mole of atoms. But here it is only 2 grams. 4 grams is 1 mole, then 2 grams is half mole, 0.5 moles of helium atoms. Understanding enough? So 1 gram of hydrogen means 1 mole of hydrogen atoms. 2 grams of helium means 0.5 moles of helium atoms, right? So he is asking, find the ratio of number of gram atoms. Number of gram atoms of hydrogen to number of gram atoms of helium. So that is 1 by 0.5. 1 divided by 0.5. That is 1 by 2. So 1 by 2 will be taken up, that it will become 2 by 1. So therefore it can be 2:1. Understanding it? So 2:1 should be the answer. Option A will perfectly match it. Got it? So going to the next question. Identify the gas whose 2 gram molecules weigh 32 grams. 2 gram molecules. 2 gram molecule means 2 moles. 2 moles weighs 32 grams. Then 1 mole weighs, if 2 moles weigh 32 grams, then 1 mole weighs 16 grams. So what is that one whose 1 mole gram molecular mass is 16 grams? Helium gram atomic mass is 4 grams. So this is not the answer. O2 gram molecular mass is 32 grams. So this is not the answer. Methane 16 grams. So this is the answer. SO2 32 plus 32, that is 64 grams. This is also not the answer. Understanding enough? So it is a perfectly matching methane molecule. Methane molecule, 1 gram molecule will weigh 16 grams. Therefore, 2 gram molecules will weigh 32 grams. 1 gram molecule 16 grams, 2 gram molecules 32 grams. Okay. Then going to the next question, find the number of gram molecules of hydrogen present in 1 gram molecule. Again, 1 gram molecule means 1 mole of H2 molecules. 1 mole of H2 molecules, right? So 1 gram molecule or 1 mole of H2 molecules, 1 mole of H2 molecules sorry. This is not 1 gram molecule of methane gas, it is 1 mole of methane. right now. 1 mole of methane molecules are given. In 1 mole of methane molecule, how many moles of hydrogen molecules are there is asking. How many moles of hydrogen molecule is there, right? So 1 gram molecule, this also we have to erase it. 1 gram molecule of methane has 4 gram atoms of hydrogen, or you can say 4 gram atoms can be taken as 2 gram molecules of H2 molecules. So the answer 2 gram molecules. He is asking gram molecules, na? Gram molecules means H2 is asking. So 2 should be the answer. So 15th question, B is the answer. Understanding? So hope you have understood this question also, right? So if he is asking gram atoms, your answer will become 4. But he is asking gram molecules, therefore answer will be 2 only. 2 only. Right now? So going to the next question here. If 1 gram of carbon contain X atoms, what will be the number of atoms in 1 gram of magnesium? What will be the number of atoms in magnesium? First of all, let us see 12 grams will contain 6 into 10 to the power of 23 carbon atoms, right? 12 grams carbon will contain 12 grams carbon will contain 6 into 10 to the power of 23 carbon atoms. Then 1 gram carbon will contain 6 into 10 to the power of 23 divided by 12 carbon atoms. Okay, this 6 into 10 to the power of 23, 1 twice 1 by 2 means 0.5 into 10 to the power of 23, or you can consider it as, or you can leave it as it is also. So these many atoms. These many atoms. 1 gram of carbon contains X atoms. What is that X here? 12 grams of carbon contains 6 into 10 to the power of 23 carbon atoms. Then 1 gram of carbon atoms contain. Carbon contains how many atoms? 0.5 into these many atoms. This itself is nothing but X. So what is the X value? 0.5 into 10 to the power of 23 is X. That many atoms is X. What will be the number of atoms in 1 gram of magnesium? Now 24 grams of magnesium contain 6 into 10 to the power of 23 magnesium atoms. Then 1 gram of magnesium will contain how much? One gram of magnesium will contain how much? 1 into 6 into 10 to the power of 23 divided by 24. That is 6 into 10 to the power of 23 divided by 24. This is 0.25 into 10 to the power of 23 atoms. Right? So in 1 gram carbon, these many atoms are there, and in 1 gram magnesium, these many atoms are there. But this magnesium atoms, he is asking to give it in terms of X number. X is 0.5 into 10 to the power of 23, but magnesium atoms in 1 gram is half of them. That is 0.25 into 10 to the power of 23. That means it is X by 2 atoms. The number of magnesium atoms are half to X, or half to the number of carbon atoms present in 1 gram carbon. Understanding? So X by 2 should be the answer. So 16th question, answer should be B, X by 2. Got? Next one. The quantity of oxygen required for complete combustion of 1 mole of an organic compound CXHYOZ is. This is actually to, we have to balance the reaction for simple understanding, see combustion. First of all, what is this combustion reaction? Combustion reaction is a reaction in which you will be burning the hydrocarbon by passing excess of oxygen gas, so that it will be completely converted into carbon dioxide and water, along with which energy also will be released. This is the energy used in running the machinery, engines of the vehicles, etc. That is why the hydrocarbon, ethane, methane, propane, butane, pentane, any of these hydrocarbons will be used as a fuel. Petrol, diesel, kerosene, all these are hydrocarbons only. Okay, na? So now, suppose as an example I am telling combustion reaction, one simple example, methane, I want to do combustion. I want to burn methane, right? So to burn methane, I have to supply oxygen, so that all the carbon will be converted into carbon dioxide and all the hydrogen also will be converted into water. But here one carbon is there, so one carbon dioxide over carbon is balanced. Here 4 hydrogens are there, here 2 only hydrogens are there, so I will take 2 H2O. So hydrogens are also balanced. Now, according to this, how many oxygen atoms are utilized in formation of complete carbon dioxide and water? That many oxygen atoms I have to consider here. That many oxygen atoms I have to use here. So how many? If it is 2 from here plus 2 from here, total 4 oxygen atoms are required. 4 oxygen atoms, but 2 oxygen atoms are there in each molecule. Therefore, if you take 2 O2 molecules, then you will be getting 4 oxygen atoms that will be forming CO2 and 2 H2O molecules. Understood this logic? So in this manner, if I write for this molecule CXHYOZ, CXHYOZ plus dash number of O2 molecules to form X carbon dioxide molecules plus X carbon dioxide molecules plus how many H2O molecules? How many H2O molecules? Y number of hydrogen atoms are there, right? So Y by 2 into 2 will become Y. That is what Y here, right? So number of oxygen atoms required are X into 2 here, right? So this is our 2x oxygen atoms here plus here how many oxygen atoms? Y number of oxygen atoms are required. Okay, na? Y number of oxygen atoms are required, and this is the total oxygen atoms. But some of the oxygen atoms are already there in this molecule. How many oxygen atoms are there? Z number of oxygen atoms are already there, right? So 2x plus Y minus Z number of oxygen atoms are required. (2x plus y minus z) number of oxygen atoms. Now this to be divided by oxygen atoms, na? So this oxygen atoms, if you divide it by 2x plus y minus z divided by 2, right? So if you simplify this one, x plus y by 4 minus z by 2. So option C will be the answer here. These many number of O2 molecules, these many number of oxygen atoms. Again I will explain. See here, carefully observe. There is a molecule CXHYOZ. Now this molecule is oxidized or combustion with O2 gas, and you got X moles of carbon dioxide molecule and Y by 2 moles of H2O molecules. In this one, whatever the total number of oxygen atoms are there in the product, they are the oxygen atoms present already in organic compound plus the oxygen you are supplying from outside. In the carbon dioxide, there are X into 2, 2x oxygen atoms are there in carbon dioxide, Y by 2 Y by 2 H2O molecules, right? So Y by 2 H2O molecule means oxygen atoms are Y oxygen atoms, right? Because each molecule will be having one oxygen atom. Understanding? So Y by 2 oxygen atoms, Y by 2 into 2, Y oxygen atoms you are having minus Z. This Z is what? This is Y by 2 only, right? Sorry. This is Y by 2 into 1 only, right? This is 1, sorry. Y by 2 oxygen atoms from H2O molecule. So that is Y by 2. So this will be Y by 2 by 2. Okay. So 2x oxygen atoms from carbon dioxide, Y by 2 oxygen atoms from water molecules minus how many oxygen atoms were already there in the molecule, right? If you subtract that one, you will be getting these many molecules. So x plus Y by 4 minus Z by 2. So this will match to number of oxygen molecules, okay, in this one. So hope you have understood. Now going to the next question. If the aluminium salt of anion X is, if the aluminium salt of anion X is Al2X3, the formula of magnesium salt of X will be, if the aluminium salt of anion X is Al2X3, then magnesium salt. Very easy, it is aluminium salt is Al2X3. We know that aluminium is Al3 plus. So if aluminium is Al3 plus, then X should be, in order to match 2 into 3 plus 6, so it should be 3 into 2. So 2 minus 3. Okay. So it is aluminium 3 plus ions and X2 minus ions. And now you want to form the compound with the magnesium. So with the magnesium, if you want to form the compound, magnesium already we know it is a plus 2 and X is already minus 2. So it can be MgX, right? So this is a divalent cation, this is a divalent anion. Both together, this option C can be the answer here, right? Then so here also I think some key mistake is given. It is given as option D, but option D will not be the answer. Option C will be the answer. So going to the next question, arrange the following in the order of increasing mass. Increasing mass. Oxygen is 16 AMU, copper is 63 AMU and nitrogen is 14 AMU. One atom of oxygen, first one, all let us write in terms of AMU only. First one atom of oxygen. One atom of oxygen will be 16 AMU. One atom of oxygen is 16 AMU. Second, that is nothing but atomic mass. Atomic mass of oxygen is nothing but mass of one atom of oxygen, that is 16 AMU. One atom of nitrogen is 14 AMU. Then third one, Third one, 1 into 10 to the power of minus 10, I think it is. Minus 10 moles of O2 gas. Right? So here, one thing what you can understand, 6 into 10 to the power of 23 1 into 10 to the power of 20, minus 10 is given. Na? 1 mole O2, that is nothing but 6 into 10 to the power of, or else let us leave these molecules. 1 into 1 mole of O2 will be weighing 32 grams. 32 grams. Right? Then 10 to the power of minus 7, 10 moles will be weighing 32 into 10 to the power of minus 10 grams. 32 into minus 10 grams. Okay, na? Last fourth one, 1 into 10 to the power of this also. Typing mistake, these are all. 1 into 10 to the power of minus 10, I think. So, 1 mole will be weighing 63 grams. Then 10 to the power of minus 10 moles will weigh how much? 63 into 10 to the power of minus 10 grams. Fourth one, 1 into 10 to the power of minus 10 moles of copper will be weighing 63 into 10 to the power of minus 10 grams. So, he is asking, arrange the following in the increasing order of mass. Increasing order of mass. Who is lowest in mass? 14 AMU, right? So, this has to be first. So, 2, 1, 4, 3. So, 2 greater than, 1 greater than this one, right? Then 3 greater than and 4. 3 greater than 4. This is the perfect answer for this question. So, going to the last question. So, this is also little more calculation is there. So, this we will discuss in tomorrow's class. This question, and also I will explain you. I think some of you might be having doubt in this question also. So, 17th and 20th question I will be explaining you tomorrow also. Okay, na? So, with this we will close the class here. So, hope you have understood. Maximum most of them are numericals only in today's class. Therefore, it will definitely take time. So, you also will try from your side, and if you are having any doubts, anyway you can ask me, you can send me your doubts. Right, and physics class will start in 10 minutes. A short break will be there for you. Okay, na? So, we'll meet tomorrow. Thank you.
Good morning to all of you. Let us continue with our worksheet. We are on homework. Question number 1. The momentum is most closely related to. They have given you 4 quantity: force, impulse, power and kinetic energy. Momentum, undoubtedly it is related to force. At the same time, it is also related to impulse directly. If you take force, it is the rate of change of linear momentum. And if you take impulse, change of linear momentum is impulse. So more closely it is related to impulse, because impulse is nothing but change of linear momentum. So your impulse is del P. This is equal to P final minus P initial. Clear to you? So for this question, answer is impulse. Number 1. Let us move to next question. Now, a metallic ball strikes a wall and falls down, whereas a tennis ball having the same mass, check, masses are equal, and velocity bounces back. Find the correct statement. Masses are equal if they will hit with same velocity and metallic ball is falling down. The change of linear momentum of metallic ball will be 0 minus mb. The magnitude part is only mb. But for tennis ball having the same mass, it is bouncing back. Suppose it is bouncing back with same velocity. If it will bounce back with same velocity, then magnitude of change of linear momentum will be equal to, P final minus P initial. It will become 2 mb. If you are taking this wall and here, this is, first you take metallic ball, it is going with V and it is falling down. In this direction, its velocity is 0. The change of linear momentum, if I take magnitude, this will be simply equal to mb. And if this is for metallic ball, and if I take change of linear momentum for your tennis ball, it has mass m moving with v and bouncing back with v, then this will become equal to 2 mb. Now, check this statement. Both suffer an equal change in momentum. Wrong statement. Tennis ball suffer a greater change in momentum. It is correct statement. Okay. So, answer will be B. Let us move to next question. The area of force time graph. I have already taught you conceptual question. On x-axis, you are taking time. On y-axis, you are taking force. You are taking area. Area will give you impulse. So, F, L, F, del T, if you take magnitude, this is F del T. So, this area gives you impulse. Answer is A. Let us move to next question. The action and reaction forces involves in Newton's third law must act on the same object. It is a wrong statement. Must act on different object, may act on different bodies, none of the above. It should act on two different bodies. Action and reaction will never act on same body. So it must act on different objects. Let us move to next question. When a horse pulls a cart, the force that helps the horse to move forward is the force. Now, when you consider the force exerted by horse on the ground, Newton's third law, same force ground will be exerting on the horse. It will have two components. The vertical component will be balancing the weight of horse, and horizontal component due to which it will be pulling the cart. The answer will be, they are asking you the force exerted by the ground on the horse. Answer will be B. Now, let us move to next question. A car accelerates on a horizontal road due to the force exerted by. Car is accelerating on a horizontal road due to the force exerted by the engine of the car, the driver of the car, the earth, the road. Road and earth both are same thing, no? Road is on earth. Guaranteed, because it is moving on horizontal road, so we will be considering the force which is exerted by road on the car. So answer, the road. Let us move to next question. When we jump out of a boat standing in water, it moves. Now in which direction you have jumped? If you are jumping in forward direction, then guaranteed your boat will be moving in backward direction. They are asking you, when we jump out of a boat standing in water, it moves backward. The direction in which person is jumping, boat will be moving in backward direction in accordance to Newton's third law. So answer here will be backward. Let us move now to question number 8. The momentum of a system is conserved always, never, in the absence of an external force on the system. You know, conservation of linear momentum. In the absence of net external force, total linear momenta of mutually interacting bodies will remain constant. So, momentum of a system of mutually interacting bodies will remain conserved when no net force will act on the system. So, answer, in the absence of an external force on the system. Let us move now to next question. Rocket works on the principle of conservation of linear momentum. Directly you can say, answer, linear momentum. Now I am on question number 10. More the mass of the gun, more will be its recoil velocity, less will be its recoil velocity. You know, mass into velocity is linear momentum. Suppose in gun bullet you have, before firing, gun is at rest and bullet is at rest. So total linear momenta of gun and bullet is 0. Suppose after firing, I am taking example, mass of bullet is small m, velocity of bullet is small v, mass of gun capital M, recoil velocity I am taking v0, v will be equal to, initial linear momenta is 0, so it is 0. So v will be minus mv by capital M. If capital M will be more, capital M is in denominator. If capital M will be more, v will be less. So here If more is the mass of a gun, less will be its recoil velocity. Answer will be B. Let us move to question number 11 now. A book of weight 10 Newton is placed on a table. So you have a table. On the table there is a book. Its weight is 10 Newton. 10 Newton is the weight. It is acting in downward direction. The force exerted by the surface of the table on the book will be, it is known as normal reaction. It is a type of contact force. So it will be acting in this direction. It is acting in this direction. This is N. Now, book is at rest. It is in equilibrium. So, net force acting on book is 0. It means N will be equal to weight. The N will be equal to 10 Newton. Let us check. You have 10 Newton here. So, answer will be 10 Newton. Let us move to next question now. We are on question number 12. The vector sum of action and reaction. Here I have a small question. When you are adding vectors, the first condition is that the point of application of all those vectors should be same. Whereas action and reaction, they are acting on different bodies. We cannot have addition of action and reaction. The vector sum of, there is no question of vector sum of action and reaction, right? But we know action and reaction, they have same magnitude. They are acting in opposite directions, equal but opposite. If by the way we want to add them, okay, no, they will never act on the same body. But if think that we want to add these two, if you want to these two, then magnitudes are equal, directions are opposite, the answer will be equal to 0. But my logic is we cannot add these two. Why we cannot add? Reason is action and reaction, they have different point of applications. The vectors which are to be added, they must act at same body, at same point of application of all the forces which you are going to add vectorially should be same. But here, for the given question is equal to 0. Let us move to question number 13 now. If a moving ball A collides with another moving ball B, then what will happen? You know, one of the fundamental conservation principle is conservation of linear momentum. Okay, now, if one body is colliding with other body, then before collision, whatever will be linear momenta of colliding bodies, after collision, the same linear momenta will be there for those bodies. Answer A and B. Before collision, the vector sum of linear momentum of A and B will be equal to, after collision, linear momentum of body A and body B. Let us see where it is. It is directly in front of you. Answer will be B. Momentum of A plus momentum of B before collision must be equal to momentum of A plus momentum of B after collision. Is it clear to you? Let us move now to question number 14. When a bullet is fired from a gun, the gun recoils due to, you will take Newton's third law, if concept is concerned, mathematically you will be taking due to principle of conservation of linear momentum. So answer here is conservation of linear momentum. Let us move to question number 15 now. A bullet in motion hits and gets embedded in solid resting on a frictionless table. What is conserved? It is basically related to collision. There are three types of collision. We will be teaching you in too much detail. Collision is a separate unit, separate chapter. We will have elastic collision, inelastic collision, perfectly inelastic collision, and inelastic collision. In perfectly inelastic collision, the two bodies will stick together and move. Right now, colliding bodies will stick together and move. In all collisions, conservation of linear momentum will be valid. Conservation of total energy will be valid. But in perfectly elastic collision, kinetic energy will be conserved, and in perfectly inelastic collision, kinetic energy will not be conserved. So here, let us check. Bullet is embedded. It means it is an example of perfectly inelastic collision. If you take collision which is perfectly inelastic, kinetic energy will not be conserved, but linear momentum and total energy will be conserved. Check what alternate they have given you. Momentum and kinetic energy. Momentum is conserved but not kinetic energy. Momentum alone sees kinetic energy alone. They have not told you about total energy. So here linear momentum will be conserved and total energy will be conserved. Total energy they are not speaking. We are only considering linear momentum. So answer here will be B. Linear momentum will be conserved. Question number 16 now. A bullet of mass. The mass of bullet 0.01 kilogram is fired from a gun. Mass of gun, they have given you 5 kilogram. If the initial speed of the bullet is, velocity of bullet, they have given you 250 meter per second. Calculate the speed with which the gun recoiled. So you want to find out velocity of gun. Just now I have told you total linear momenta of bullet and gun before firing is 0. Bullet is inside gun, gun is at rest, bullet is at rest. So velocities of both bullet and gun 0. So total linear momenta will be 0. So 0 will be equal to after firing mass of bullet, velocity of bullet, mass of gun, velocity of gun. So velocity of gun will be equal to minus mass of bullet, velocity of bullet by mass of gun equal to minus. Minus sign is indicating, when you are considering minus sign, it means that gun will move in a direction opposite to the direction of motion of bullet. So it is recoiling. How much it will be? Minus mb 10 to the power minus 2.01, no? Velocity of bullet 250, mass of gun is 5. So 5 will become 50. So it will become 0.5 meter per second, and minus sign is there, the minus. But here one thing is there. They are asking you calculate the speed with which gun recoil. Already word recoil is there. When recoil is there, minus sign we should not consider. So my answer will be 0.5. Now check 0.5 where it is. Okay, no? The 0.5 is here and they have given a minus sign. Actually, recoil word is already there. Answer will be plus 0.5. Benefit of doubt, let us take minus 0.5 meter per second. Understood clearly? Let us move now to next question. Newton's third law. Now we are on homework. Newton's third law of motion can be used to explain passenger in a bus. That is Newton's first law. You know that, law of inertia. You want third law, swimming of a man. Okay, no? You are pushing water backward, your body is moving in forward direction. So this is third law. The motion of a rocket, gas is ejected from the rear of rocket in downward direction and rocket is moving in upward direction. So Newton's third law of motion can be used to explain these two. So answer both B and C. Clear to you? Let us move to next question now. A body of mass m and velocity u strikes a wall. So I have a wall and I have a body. It has mass m. It is moving and hitting the wall with velocity u, and it is returning with velocity v. The change in linear momentum. I have told you, whenever we talk about change, change is always final minus initial. Clear now? So my final linear momentum, let us take this direction as plus I, positive x direction, this one as minus I, negative x direction. So change of linear momentum, P final minus P initial. Okay. Now P final is how much? M V minus I minus P initial M U plus I. How much you got? Minus MV plus MU. So your answer is minus MV plus U. Here you have I. What do you mean by that? Okay, if I am considering like this, it means that the magnitude of change of linear momentum will be in the direction in which ball had rebounded. Okay, it will be mv plus u away from wall. So here you answer, you check, answer will be minus mv plus u, and it is magnitude of change of linear momentum of the body. Let us move to next question. Object A of mass 2 kilogram. So you have M A 2 kilogram, V A 3 meter per second. It is colliding head on with object B. M B, they have given you 1 kilogram and it is moving in opposite direction with velocity. So I have A if I take it, it is moving in positive x direction. It is 2 kilogram moving with 3 meter per second, and here you have B. It has mass 1 kilogram. It is moving with velocity 4 meter per second. 4 meter per second. After collision, find the common velocity of both the object. They want to say you after collision they stick together, and what will be their common velocity. So initial linear momentum will be MAVA minus MBVB. Common velocity they are asking. MA plus MB into V. 2 into 3 minus 1 into 4. Clear to you? This is equal to 2 plus 1 into V. 6 minus 4 is 2 equal to 3V. So V will become 2 by 3 meter per second. And what will be the direction? Direction will be that of A, because this quantity is larger. You got plus, and plus sign I have taken in positive x direction. So your answer is combinedly body will move in this direction. Their mass is 3 kg, and it will be moving with velocity 2 by 3 meter per second. Is it clear to you? Understood? Mass is 213. Velocity you take 3 and opposite direction 4. Clear to you? Let us move now to next question. A body of mass 5 kilogram moving with a velocity 10 meter per second collides with another body of mass 20 kilogram at rest and comes to rest. Find the velocity of second body due to collision. So you will have a body of mass, this is 5 kilogram, it is moving with velocity 10 meter per second. It is colliding with another body of mass 20 kg. So it is colliding with a body of mass 20 kg and it is at rest. And after collision, what is happening? This 5 kg is coming to rest. Find the velocity of second body. Second body means 20 kg. With what velocity it will move? So your initial linear momentum is how much? So 5 into 10 plus 20 into 0. This will be equal to 5 into 0 plus 20 into V. Before collision linear momenta must be equal to after collision linear momenta. So you will have 5 into 10, 50. 20 into 0 is 0. 5 into 0 is 0. This will be equal to 20 into V. V equal to 5 by 2. 0, 0 cancel. 2.5 meter per second. It means that if a 5 kilogram body which is moving with velocity 10 meter per second will be heating head-on collision with another body of mass 20 kilogram which is at rest. After collision, if 5 kilogram body will come to rest, then 20 kilogram body will be moving with velocity 2.5 meter per second in the same direction. The direction in which body of mass 5 kilogram was moving. Directly you have used conservation of linear momentum. Tell me, understood clearly? Now, let us move to next question. Now I am on question number 5. A particle of mass m moving with a velocity v strikes a stationary particle of mass 2m and stick to it perfectly in elastic collision. Then find the speed of the system. Any kind of collision. Okay, no. Bodies which are colliding are mutually interacting bodies. No external force is acting on interacting bodies. So total linear momenta of the system will remain conserved. Before collision, whatever will be linear momenta, after collision, same linear momenta would be there. So now you have a particle of mass m. It is moving with velocity v. It is striking a particle of mass 2m. It is at rest and stick to it. It means now mass is 3m. Find the speed of the system. They are asking you v. The initial linear momenta mb plus 2m into 0 will become 3m into v. So mv will be equal to 3m. Let us take as v dash, 3m v dash. Now m is cancelled. V dash will be v by 3. Your answer will be, if the two bodies collide together and they are sticking and one mass is moving, that mass is 3m, then its velocity will become v by 3 in the same direction. Clear to you? Let us move now to next question. You have a neutron, okay, one of the nucleon, one particle, inside any nucleus of an atom, you have proton and neutron. You have a neutron, mass of neutron they have given you. Mass of neutron 1.67 10 to the power minus 27 kilogram. And they have given you its velocity. Velocity of neutron 10 to the power 8 meter per second. Collides with a deuteron at rest and sticks to it. Now, they have given you mass of deuteron. They have given you 3.34 10 to the power minus 27 kilogram. And they say you deuteron is at rest. So, initial velocity of deuteron is 0. If the mass of deuteron is this, find the speed of the combination. Again they say you that they combine. When they will combine, masses will be added. Okay, no. So what will happen? You will have Mn, Vn, Md, Vd. This will be equal to Mn plus Md into V common. That is combination velocity. So it will be 1.67, okay, into 10 to the power minus 27 into Vn 10 to the power 8 plus MTVD. अब Vd is 0, not directly take 0. अब it is 1.67 plus 3.34. Okay? This into 10 to the power minus 27. And they are asking you find the speed of common. So this is V common. Okay, no? Then now this quantity is 0. 10 to the power minus 27 I have cancelled. So your V common will be equal to V common. It is 1.67 10 to the power 8 by 3.34 is 2 times of 1.67. So 2 plus 1, 3 into 1.67 cancelled. It will become 10 to the power 8 by 3 meter per second. Further also you can say 3.33 10 to the power 7. Okay, no? Let it be 10 to the power 8 by 3 meter per second. More physical concept you are obtaining from this answer. Now, let us move to next question. A batsman has a choice to use a heavy or light bat while facing a fast bowler. Fast bowler means the linear momentum of ball will be more. He will prefer. Okay, the before collision, your linear momentum is mv, mass of ball into velocity of ball, right? Now, this one they are telling you, they are considering a light or heavy bat. When you consider a bat, okay, no, that this must be equal to minus of mass of bat and velocity of bat. Mass of bat, velocity of bat. Okay, no? The velocity of bat will be minus mv by mass of bat. The velocity of bat is proportional to 1 by mass of bat because this quantity is constant. Right? The velocity of recoil will be less if you are taking heavy bat. Bat will move in backward direction by less distance. Certainly, when batsman is facing a fast bowler, means linear momentum of ball, if it is high, more, what he should do? He must use a heavy bat, correct? So that recoil speed of bat towards himself, towards batsman will be less. The answer, he will prefer heavy bat so he can handle it firmly. Clear to you? Let us move now to next question. A 60-gram bullet fired from a 5-kilogram gun leaps with a speed of 500 meters per second. Find the speed with which gun recoil. So again same with a mass of bullet 60 gram. It means that 60 into 10 to the power minus 3 kilogram. Now, it is moving with the speed, velocity of bullet 500 meter per second. Mass of gun, they have given you 5 kilogram. Find the speed with which the gun is recoiling. The initial linear momentum 0, mass of bullet, velocity of bullet, mass of gun, velocity of gun, velocity of gun, minus mass of bullet, velocity of bullet, mass of gun. This will be equal to minus mass of bullet 60 10 to the power minus 3. Velocity 500, mass of gun 5. Clear? What I do, this 5 you cancel, it is 100. 1, 2, 3 cancel. This 1, 2, 3 cancel. How much you got? Minus 6 meter per second. So your gun will be recoiling, okay, no, with speed 6 meter per second. Recoiling means the direction in which bullet is moving, opposite to that direction gun will move with velocity 6 meter per second. Undoubtedly, it is also a very large speed because some person will be holding that and he'll have to stop this. Whether if suppose he is keeping gun here, then the gun will be hitting this with speed 6 meter per second. Is it clear to you? Let us move now to next question. Now I am on question number 9. A 10-gram bullet traveling at 200 meter per second strikes. So mass of bullet 10 gram 10 to the power minus 3 kilogram. It is traveling. Velocity of bullet 200 meter per second, and it is striking and remains embedded in a target. Mass of target 2 kilogram. It is embedded. It means that collision is perfectly inelastic, which is originally at rest. So initial velocity of target is 0. And now they are free to move. At what speed does the target move? Again, perfectly inelastic collision. Initial linear momenta must be equal to final linear momenta. The initial linear momenta is 0 now, beta. So it will be mvvb plus 0. mtvt will be 0 because vt is 0. And it is embedded. So this will be equal to mb plus mt into v. Am I right? So v will be equal to how much? mb vb by mb plus mt. Now mb is 10 to the power minus 2. This is nothing but 10 to the power minus 2 kilogram. Vb 200 by mb plus mt. So this will become 2 kilogram plus 10 to the power minus 2, 0.01. Clear to you? So you are getting 10 to the power minus 2, and here you have 2 zeros. These 2 zeros cancel. 2 by 2.01. Nearly you will be taking 1 meter per second. So your answer is nearly 1 meter per second. Slightly, very small, slightly less than 1. But answer is nearly 1 meter per second. You can neglect 10 to the power minus 2 kilogram in comparison to 2 kilogram. Now, let us move now to next question. Now I am on number 10. A man fires a bullet of mass 200 gram. So, you will have a bullet, its mass is 200 gram, means 0.2 kilogram, with a speed of 5 meter per second. Velocity of bullet is 5 meter per second. The mass of gun 1 kilogram, including the mass of bullet. Including this word you must consider. It means that mass of gun plus mass of bullet is 1 kilogram. By what velocity the gun rebound backward? In the beginning it is at rest. So it is 0. This will be equal to mass of bullet, velocity of bullet plus mass of gun, velocity of gun. So when you take this will be giving you mass of gun will be 1 minus mass of bullet 0.2. So you will have 0.8 kilogram. This is unit is kilogram. Is it clear to you? Is it clear? If you understood this, then what is happening? We want velocity of gun minus mass of bullet, velocity of bullet by mass of gun minus mass of bullet 0.2, velocity of bullet is 5 divided by mass of gun 0.8. Here, so this will go 4 times 5 by 4, 1.25 meter per second. Clear to you? Minus sign is indicating that gun will be moving in a direction opposite to the direction of motion of bullet. Bullet is moving in forward direction, gun will be moving in backward direction with velocity 1.25 meter per second. Let us move now to next question. Okay, no, I am now on question number 11 now. A gun of mass 3 kilogram, including bullets, fired a bullet of mass 30 gram. So your mass of gun is 3 kilogram. Think to clear your fundamental concepts in our CBC book, how many problems they are giving you. All fundamental basic problems. Your basic concept will be crystal clear while solving so many problems on same concepts. Okay, so all of you must follow our books, resonance books, whatever they are giving you. Correct? First, you must solve the questions or problems, whatever they are giving you in our resonance material. One of the finest material. When you will be coming here, then we'll continue in a systematic way. Then new books you will be getting. At this time you are using only CBC book. Right now, we will be following each and every, first we will be solving each and every problem from our resonance material. Check, mass of gun 3 kilogram. Again, a gun of mass 3 kilogram including bullets, fires a bullet. Okay, actually they should say including a bullet, not bullets. It may be possible. Okay, no, AK-47, so many bullets will be there. Right now, but here in the given problem, they say you there is gun and there is a bullet. Understanding now? It is not containing many bullets. The mass of gun 3 kilogram including bullets. In this mass of bullet you add. Fires a bullet of mass 3, bullet of mass 30 gram. This is 30 gram. 30 gram will become 30 into 10 to the power minus 3 kilogram. So this is 3 10 to the power minus 2 kilogram. If you want to take, again it will be neglected. The mass of gun will be 3 minus 0.03 kilogram. It will become 2.97 kilogram. We can neglect that. The bullet takes 0.003 second to move through the barrel. Del T they are giving you 0.003 second. Okay, and acquires a velocity. It is acquiring a velocity of 100 meter per second. Calculate the velocity with which the gun recoil. Okay, no? So here you check they are telling you it is moving for, okay, no, only 0.003 second, and it is acquiring velocity of 100 meter per second. Again, they are asking you velocity of recoil. When you consider velocity of recoil, you will be considering mass of bullet and velocity of bullet. That will be equal to mass of gun into velocity of gun. Okay, no, whatever time it takes, F into del T will be taken as change of linear momentum. But why to go for F into del T? Because if you are going for F, your M into U is 0. F will become same mb by del T. Am I right? Into del T. Del T will be cancelled. Again it will become m into V for the gun. So we will be considering just this velocity and will be taking mass of bullet. This is already told you acquires a velocity BB. So mass of bullet, velocity of bullet will be minus mass of gun, velocity of gun. So velocity of gun will be mass of bullet 0.03. Okay, no, they have given you kilogram. This into velocity of bullet, they have given you 100. This divided by mass of gun. Actually, mass of gun is this. This part you can neglect. You just take 3. So it will become 3 by 3. Minus sign is there. Minus sign minus 1 meter per second. Minus sign is only indicating that gun is just recoiling. If you want to take change of linear momentum impulse, then also same answer you will get. F mv minus 0, okay, by del T. An impulse, if you take F into del T, then mv by del T into del T. Check, del T is cancelled. Again you are getting F into del T is mv. Clear to you? The answer is 1 meter per second. Let us move to next question. A shell of mass 0.02 kilogram. You have mass of shell 0.02 kilogram means 2 into 10 to the power minus 2 kilogram is fired from a cannon of mass of cannon. They have given you 100 kilogram. The speed of shell fired is 80 meter per second. So velocity of shell is 80 meter per second. They are asking you recoil speed of cannon. Already so many times we have written. So directly can I write? You will have velocity of cannon equal to minus mass of shell, velocity of shell by mass of cannon. This will be recoil speed. Substitute the values. Minus mass of shell 2 10 to the power minus 2 into 100 divided by mass of cannon is 100. Okay, 100 cancelled, minus 2 into 10 to the power minus 2. 1 minute. They have given you mass of shell 2 10 to the power minus 2. Velocity of shell they have given you only 80 meter per second. So please check that you have this as 80 only. So we are taking now 80 and mass of cannon is 100. Okay, no? So 1010 cancel. This is your 8 into 2, 16 10 to the power minus 2 by 10. So this answer, okay, this answer will be changed now. It will become 16 into minus 16 into 10 to the power minus 3 minus 1.6 10 to the power minus 2 meter per second. So speed of cannon will be 1.6 10 to the power minus 2 meter per second. Negative sign again indicates that in whatever direction shell will move, cannon will move in the backward direction. Now, let us move to next problem 13. They have given you a figure. There is a table. On the table, they have kept a book. A book lying on a table exerts a force on the table which is equal to weight of the book. They have shown you here mj. This is the force of action. As the system is at rest, the net force on it is 0. Draw the free body diagram of the book and table. N is normal reaction on the book, N is reaction force on the table by ground, and Wt is the weight of the table. I'll have to discuss free body diagram first. Okay, no. Here they are telling you draw the free body diagram of the book and table. If you take, I will be talking in much detail about free body diagram a bit later on after completing this. First you take, this is the book. On the book, mj is acting downward and normal reaction, N is acting upward. In the figure they have given you R. So let us take this as R. mg will be equal to R because these two are equal but opposite, but they are not considered to be action and reaction forces. Clear to you? Now, free body diagram of table. If I show table as a particle, if I show this table as a particle, so what is happening? They are telling you, yeah, N is reaction force on the table by ground. So there must be some mass of table. They have not shown you what is the mass of table. They say only book is lying on the table. Okay, no? The force of action, system at rest, net force on it 0. Free body diagram of book I have drawn to you, for you, and table. N is normal reaction on the book. N is normal reaction on the book already they have taken up. This one already they have taken up. Now, N is reaction force on the table by ground. So, beta this N, this line is wrong. Here it should be R, and N is reaction force on the table by ground. So, here is N, normal reaction, okay, on the table by ground, and Wt is acting here. Clear to you? And book is also exerting force here. This is mg. You have to consider on the table what forces are acting. On the table, okay, first, its weight is acting in downward direction. And ground is exerting force on upward direction. And book is exerting force in downward direction. So, you will have N upward, weight of table acting downward, and mg you have taken, that force is acting also on the table. That force is also acting downward, and table is at rest. So, normal reaction of ground on the table must be equal to weight of table plus weight of the book. Clear to you? Let us move now to next question. draw the free body diagram. Means I think that all are free body diagram question now. Okay, no? All are free body diagram question. So let me discuss first. What is normal reaction? What is free body diagram? What is tension? And then those questions we will do which are based on free body diagram. Clear to you? First, what is normal reaction? If a body is in contact with a surface, okay, no, its weight is acting in downward direction. Contact force is of two types. One, normal reaction, the force which will act normally, means at right angle to the surfaces in contact. Because you are interested in knowing about body, that right angle to surface of the body, whatever force will act, that force will be known as normal reaction. Basically, macroscopically, it is electromagnetic force. Weight is gravitational force. Normal reaction is electromagnetic force. It is happening due to molecular interactions, okay, of the molecules which are present on the surfaces of the two bodies which are in contact with each other. So, normal reaction will act here. The body, you are treating it just like a particle. So, normal reaction here will act in this direction. If body is at rest, then guaranteed net force acting on the body must be equal to 0. Means weight and normal reaction, these two must be equal. It means N will be equal to mg. Okay, no? This one I have taken when surface is horizontal. Now suppose I have an inclined plane. On this inclined plane, these surfaces are in contact. Let us suppose angle of inclination of the plane is theta. Okay, no. Just now I have told you, normal reaction is the force which will act normal to the surfaces in contact. It is originating due to molecular interaction, so it is a contact force. It will always act normal to surfaces in contact. So here, normal reaction will act like this beta. Weight is acting in vertically downward direction. If this angle is theta, then this angle I will take like this. This angle will be 90 minus theta. So this angle will be theta. Understanding now? Now, mg you resolve. When you are resolving mg in this direction, it will be mg cos theta, and in this side it will be mg sin theta. Now, body may be sliding along the inclined plane. I am not at all interested. We want to know only about normal reaction. So, when we will talk about normal reaction, your end body is not moving above the inclined plane. It is always in contact with the inclined plane. It means that at right angle to inclined plane, net force must be equal to 0. It means here normal reaction will become mj cos theta. Tell me, are you understanding what is normal reaction? Clear? Normal reaction is a contact force, number one. Number two, normal reaction force will always act at right angle, normal, to the surfaces which are in contact with each other. I have shown you two surfaces, one horizontal surface, other inclined surface. In both times, whatever will be the normal reaction, I have shown you in the figure. Next, free body diagram. It is a technique for solving problems related to Newton's laws of motion, friction, work power energy. In so many chapters, we use concept of free body diagram. What is free body diagram? Okay, simple. In a given problem, there will be many bodies. Okay, now, step one, isolate first one body and then identify how many forces are acting on the body. Guaranteed, you are solving the problem. Your physical system will be on earth. The one force will be its weight. If it is in contact with other surface, there will be many contact forces. There will be frictional force. There will be normal reaction. Understanding me? If it is connected with a string or rope, there will be tension. So, first, in front of you, many bodies are there. First, identify one body. Concentrate on one body. Then, identify all the forces which are acting on that body. Some examples of those forces I have given you. Weight, normal reaction, tension, frictional force, all those forces you identify, whatever forces are acting. And now you take factor sum of all those forces. It is always better that all the forces you resolve in two components along x direction, along y direction, and then find the resultant by using concept of vector addition. Right? Whatever will be net force equate to m into a. That is for one body. Now, in the given problem, there will be many bodies. Maybe, may not be. If there are many bodies, now same way concentrate on second body, third body, fourth body. Every body, as many bodies are present in the given problem. For every body, identify all the forces. Means point of application should be your body. As many forces will have point of application your body, identify all those forces, find the resultant by using concept of vectors, and net force in a particular direction equate to ma. Suppose you have taken x and y direction, you have taken resultant of all the forces along x direction, then F net along x equate to max. Now you are taking resultant of all the forces along y direction, then you are taking F net along y direction will be m into ay. Clear to you? Understood what is free body diagram? Free body means first make body free from other bodies and then find all the forces which are acting on that body and find the resultant. And same operation you do for all other bodies. It is called free body diagram. I can quote metaphysical examples also. when you will be coming near me, okay, we will be telling you about metaphysical examples also for this. Okay, no? A very simple example I remember, but leave it, I'll be telling you later on. Did you understand free body diagram? Let us draw some free body diagram. One is already here. This is the simplest free body diagram. Simplest. A block, a book is kept on table. Surface of table is horizontal. You want to draw free body diagram for this book or block. In horizontal direction, okay, there may be static friction. With damn care. In vertical direction, only two forces are acting, weight and normal reaction. One is gravitational force, other is contact force. Only two forces are acting. So, I have taken this body, on this body I have taken 2 W and N, and we are equating N equal to W. Simple free body diagram. Okay, but because time is over, you will have math class also. I'll continue with free body diagram tomorrow. Along with that, I will teach you tension, and our journey for solving problems will be continued on. Okay, let me check how many problems from this assignment we have not done. This is 1. Okay, class work. Yes. Okay, from class work that side is 15, 14, 14. 14 and 15 we have not done. So after learning free body diagram, we'll go for that. Okay, now, these questions will be solving tomorrow. First, a bit in more depth, we'll be learning how to draw free body diagram, how to use concept of tension, and then all these problems will solve. Today, I'm keeping till here. Okay, no? We'll continue tomorrow. Thank you for today. Have a nice day. Now, 10-minute break you would have. After that, your math class will start. Again, thanking to all of you.
मैथ्स का बुक Good morning, students. So yesterday we have discussed sets and operations of set, and I've given you homework based on it. So today we'll be doing questions of that, and then we'll be doing Venn diagram. Yesterday we saw Venn diagram also, but today also we'll be continuing the Venn diagram, and we'll see what happens for 3 sets. Okay, so let's start. I hope all of you have done the homework. Okay, let U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. P is equal to 1, 2, 5. Q is equal to 6, 7. Then P intersection Q dash, right? P intersection Q dash is what? Okay, so first we need to find Q dash, right? What will be Q dash? If Q is this, right, Q dash will be what? Everything but 6 and 7. So 1, 2, 3, 4, 5, 8, 9 and 10. Right, 1, 2, 3, 4, 5, 8, 9, 10. Right, then P we already have, right? P is how much? 1, 2 and 5. Now what is common between P, this and this? P intersection Q dash. What is common? Common is what? 1, 2 and 5. Right? Common is what? 1, 2 and 5. And what is 1, 2, 5? 1, 2, 5 is nothing but P. Right? 1, 2, 5 is nothing but P. So this is the answer. Right? First question. Next, what will be the intersections of set A is equal to 1, 2, 3, 4 and set B equal to 3, 4, 5. Right? 1, 2, 3, 4 and set B equal to 3, 4, 5. Right? So intersection they are asking. So what is common? Basically asking A intersection B. And what is common between A and B? A and B common is what? 3 and 4. Right? 3 and 4. So the answer is what? 3, 4. So again option A. Right? The only thing common between A and B is what? 3, 4. Right? Okay. Let's do the next. Third, what will be the union of sets? Set A is 1, 2, 3, 4, 9 and set B is 6, 7, 8. Right? Union. They are asking what is union. So A union B. Correct? If you see, there is nothing common between A and B. Right? There is nothing common between A and B. So all the elements in set A or set B, both will become. Right? So set A is how much? 1, 2, 3, 4, 9, then 6, 7, 8. Right? So basically everything, just 5 is not there in anyone. Right? So which is the option? I think 1, 2, 3, 4, 6, 7, 8, 9. There is option D. Right? Option D. In this 8 is not there. That's why this is rejected. In this 3 is not there. This is why it is rejected. And in this too, I think 7 and 6 is not there. Right? So that's why the answer is what? Answer is option D. Right? I hope this is clear to everyone. Option D. Next. Fourth. If x is equal to 4 to the power n minus 3n minus 1, y is equal to 9n minus 1, where n is the set of natural numbers, then x union y is equal to what? Right? X union y is equal to what? Okay. So first let's find out what is set x and then we'll find out what is set y and then we'll find the union. Correct? So for x, if I put here n equal to 1. Why? Because it is natural number. Na? If I put n equal to 1, what will I get? 4 minus 3 minus 1, which is what? 0. Right? If I put n equal to 1, I am going to get 0. Right? Okay. If I put n equal to 2, so what I'll get? 4 square, which is 16. 16 minus 6 minus 1. So it is going to be 9. Right? It is going to be what? 9. If I put n equal to 2. Okay. If I put n equal to 3. N equal to 3. So 4 cube is how much? 64. Right? 64 minus 9 is going to be how much? 55 minus 1 is 54. So we'll get 54. And after that there will be a big number. Okay. We don't need to find it right now, but we are just getting to know it is 0, 9, 54 and so on. Correct? Okay. Let's find out y. Let's find out y. So for y, if I put n equal to 0, I'm going to get 0. If I put n equal to 2, I'm going to get 9. If I put n equal to 3, I'll get how much? 9 into 3 minus 1, which is what? 18. Then 27, right? Then so on. Correct? X and this is what? Y. Correct? Okay. Now, what will be x union y? Right? What will be x union y? That is the question. Right? X union y. So, x union y has to be a set which contains both the element of what? X and y. So, if I continue y, at one point it is a multiple of 9. Right? So, at one point I will be getting 54 also. Right? In set A, in set X, I have 0, 9 and 54. But in set Y, we have more elements, including 0, 9 and 54. So, which one is the bigger set? Bigger set is what? Bigger set is Y. Right? So, I can say from here that X is a subset of Y. Right? X is a subset of Y. And if X is a subset of Y, X union Y will be equal to nothing but Y. Right? X union Y will be nothing but Y. So the answer for this will be what? Option D. Right? The answer for this question will be what? X union Y is option D. Okay? I hope this is clear to everyone. Fifth. the relation A union B is equal to A intersection B can be true when, right? So A union B is equal to A intersection B when this can be true, right? So when it can be true, if suppose A is equal to B, right? If A is equal to B, so let's say this is set A, right? And let's say this is set B, right? So A, if I take A union B, I am gonna get same A or B, right? If I take A intersection B, again I am gonna get same A or B, right? So that is why when it is equal, it is correct. Okay. If A is equal to 5, right? If A is equal to 5, then A union B will be equal to what? B, right? Because A is 5. So with 5, if I take union, I'll get B only, and A intersection B will be how much? What? 5. So this is not correct, right? Because we need, what do we need? We need A union B. We need A union B should be equal to what? A intersection B. So this is not correct. If A is a subset of B, again it will not be correct, because this will be the diagram, right? This is A, this is B. So if A is a subset of B, right, A intersection A union B will be B, and A intersection B will be A, right? They both are not equal, right? Understood? And last option, when A and B are disjoint set. If A and B are disjoint, there is nothing common. This is A, this is B. Then what can I say? That A intersection B will be equal to what? 5. Right? A intersection B will be equal to what? 5. Am I clear? So A intersection B is 5. That is why it is also not correct. Understood? Because A union B will be what? Both A and B. And this is what? 5. So they can't be what? Equal. That is why the correct option for this is what? Option A only. A equal to B. Okay. I hope this is clear to everyone. Next. Okay, question number 6. If A intersection B is equal to A intersection B is equal to A is true if, right? A intersection B is equal to A is true if, what, when it will be true? So, see here, A intersection B is equal to A. Okay, now, if I want to draw the diagram for this, how it can be? If B is bigger and A is small, right? Then only A intersection B will be equal to what? A, right? So it means that A is a subset of B, right? A is a subset of B, correct? So that is why the answer will again be what? A, right? If A is not a subset of B, then whether A intersection B will be equal to A. Let's see, second option. So let's say this is B, right? And this is A. Right? In this, A is not a subset of B. Right? I have taken something common. So wait. Let's say this is A. Right? So A intersection B will not be equal to what? A. Right? So that is why it is not a correct answer. Right? Then next, B is a subset of A. If B is a subset of A, that is like this. A is this and B is this, right? This is B. So how can A intersection B will be equal to B? This is not possible, right? A intersection B equal to B will not be equal to A will not be possible, right? Because it is actually equal to what? B, right? This is not possible. So that is why this is also not correct, right? And if B is equal to 5, B is equal to what? 5. If B is 5, then A intersection B, then A intersection B will be equal to 5, right? Because if I take an intersection with a null set, right, there is going to be nothing common between this and this. That is why we are going to get what? 5. Understood? So this is not correct again. So answer is what? Option A. B, C, D all are what? Wrong. Understood? Okay. Next. If U is equal to 1, 2, 3, 4, 5, 6, 7, A is equal to 1, 2, 3, 4, 5, B is equal to 1, 3, 5, 7, then A dash B, A dash minus B is equal to what, right? A dash minus B is equal to what in this case, right? So if U is this, A is this, B is this, then A dash minus B is equal to what? Okay. First we'll find out what is A dash. So A dash will be what? Everything but 1, 2, 3, 4, 5. So it will be what? 6 and 7, right? And we already know what is B. B is how much? 1, 3, 5 and 7. So A dash minus B will be what? Element which are present in A but not in B, right? Element which are present in A but not in B. So in C, if 7 is present in both of them, right? So it will be option only 6, right? Only 6. So that is why the answer will be what? D. Answer will be what? D. Understood? I hope this is clear to everyone, right? This question is clear to everyone. Let's do the next one. A. 8, sorry. If A equal to 1, 2, 3 till 9 and B is equal to 2, 3, 4, 5, 7, 8, then A minus B is given by, right? Then A minus B is given by. Okay. So how I am going to do this? If A is this and B is this, correct? So if I want to write down all the elements of A, I'll get 1, 2, 3, 4, 5, 6, 7, 8 and 9, right? And if I want to do B, if I write down B, B will be what? 2, 3, 4, 5, 7 and 8, right? A is this, B is this, then, right, we need to find A minus B. So element which are present only in A and not in B. So what I will do, see, 2 and 2 are common, so I will remove this 3 common, 4 common, 5 common, then 7 common and then 8 common. Right, so which elements are left here? The elements which are left is what? 1, 6 and 9. So the answer will be what? 1, 6, 9. Right, so the answer is what? Option B. Right, the answer will be what? Option B. Alright, I hope I am clear with this one. 8. Okay, next. Which of the following two sets are disjoint set? Right, which of the following two sets are what? Disjoint sets. Okay, so there has to be nothing common in the sets, right? So in the first one, if I see 3 and 3 are common, right? And 1 and 1 are also common, so this is not a disjoint set, right? For disjoint, if you remember, there has to be nothing common in them. This has to be A, this has to be B, right? If option B, in option B, everything is common, 1, 2, 3, 1, 2, 3. So this can't also be true, right? In option C, 1, 3, 5 and 2, 3, 4, right? 1, 3, 5 and 2, 3, 4. So 3 and 3. Again, it is not the right answer. Right? Again, this is not the right answer. And option D, 1, 3, 5 and 2, 4, 6. Right? 1, 3, 5 and 2, 4, 6. So these are what? Odd numbers. Right? And these are what? Even numbers. Right? So these are odd numbers, these are even numbers. So what can I say? Correct option is option D. There is nothing common between A, B, C and D. Alright, I hope I am clear with this one. Next. Let A be the set of odd numbers and B be the set of even numbers. Then find A intersection B. Then find A intersection B. Right. So, if A is the set of odd numbers, right. So, if I want to list down odd numbers, right. So, I will write 1, 3, 5, 7, so on. Right. And B will be what? Set of even numbers. So 2, 4, 6, if in fact 0 will also be there, 8, so on. Right. So what kind of numbers will be coming? Right. What kind of numbers will be coming? If I say set of prime numbers, that is incorrect. Right. Because we need to find, there we want to find intersection. Right. We need to find intersection. A intersection B. So there is nothing common between A and B. Right. If there is nothing common between A and B. If there is nothing common between A and B, I can say that A intersection B will be equal to what? 5, right? Which is an empty set. है ना? Empty set मतलब option C, right? Okay, I hope this is clear to everyone. if suppose this question is asking A union B, right, then they have to specify the set of odd natural numbers, right, and this has to be also natural numbers, right. So odd natural number and set of even natural number, if I include, 0 will not be coming, so I will get all the set of natural numbers. This would have been the answer for A union B, right, for A union B, that is natural numbers. But for A intersection B, between odd numbers and even numbers, there is nothing common, right? So that is why we will not include this. Okay, I hope this is clear to everyone, right? All right, next. 11th, if A is equal to 2, 3, 4, 5, 2, 3, 4, 6, 8, B is this, C is this, find A intersection B union A intersection C. Okay, so what I will do, I will find A intersection B first, right? A intersection B. So what is common between A and B? If I see 3 is common between both of them, then 4 is also common between both of them. But 5 and 10 are not common. So A intersection B is what? 3, 4. Right? Then A intersection C. A intersection C. So 2, 3, 4, 6, 8 and 4. Right? So if I want to take another color. So see, 4 is common between them. Right? 4 is common, then 6 is also common, right? Then 8 is also common, right? 4, 6 and 8. So can I say A intersection C will be what? 4, 6 and 8, right? 4, 6 and 8. Now what they are asking? They are asking the union of these two, right? They are asking the union of these two. So for A intersection B union A intersection C, it will be how much? 3, 4, 6 and 8, right? It will be how much? 3, 4, 6 and 8. Okay, I hope I am clear with this one. So the correct option is what? Option C, right? The correct option for this is what? Option C. 11th is what? Option C. Okay, I hope I am clear with this. Now let's go to the next one. 12th, given the sets A 1, 2, 3, B 3, 4, C 4, 5, 6, then A union B intersection C is what? A union B intersection C is what? So for first what I will do, I will find B intersection C, right? B intersection C. So what is common between B and C? It is 4, right? Just 4 is common between B and C, if you see here, right? And then what they are asking, A union, right? A is what? 1, 2, 3. Correct? So if I take a union of A and B intersection C, I am going to get 1, 2, 3 and 4. Right? 1, 2, 3 and 4. So the correct option is what? Option B. Right? I hope I am clear with this one. How to find A union B for this question. I guess that's it. Okay. So we have finished all the discussion of the worksheet. Now I will be doing the next topic for today, which is Venn diagram. Right? So the today's topic is what? Venn diagram. It's a very easy topic. So we'll be discussing about Venn diagram and then I'll be giving you homework. Okay, it's a very small topic. So I guess it will be finishing early. Right? But let's see what are the possibilities of Venn diagram. Right? So yesterday we have discussed, right, Venn diagram. Right. So yesterday we had discussed, let's say this is a universal set, right? This is a universal set, and let this be what? A, right? This be what? A, correct? And let's say this be let's say this be what? B, right? Let this be A and let this be what? B. So what will be A union B? Right? The question is what? What is A union B? So we have discussed A union B will be all the three parts, right? A union B will be all the three parts. So I can say it will be this, right? This is what? A union B. Okay? For two sets, this is what A union B is, right? Okay. Now if say, now let's say if there is a same question, right? This is A union B, so I'll write it here. A union B, correct? If I suppose make again A, right, and let this be B, right? So what will be this part? This part is nothing but A intersection B, right? This is nothing but A intersection B. Okay, so this is A union B and this is A intersection B. Okay, so I hope it is clear through Venn diagram. Yesterday also we have seen this, but we are revising it for Venn diagram today. So this is A union B and this is A intersection B. Okay, for two sets. Next, let's say I need to find out, this is A, right, and this is B, and I want to find out A minus B, right? I want to find out A minus B. So what will be A minus B? Elements which are present in A but not in B, right? Elements which are present in A but not in B. So the answer is what? A minus, this is what A minus B is, correct? Okay. Now let's say I want to find out B minus A, right? I want to find out B minus A, correct? So for B minus A, the answer will be what? This part, right? This is what? B minus A. All elements are present in B but not in A. What we will do to find B minus A? We will remove the common elements between A and B from B, right? From B we will remove the common elements between A and B. Okay, okay, I hope this is clear to everyone. Then let's do one more. Then next we learned about symmetric difference. So let's say this is A, right, and this will be B, right? So symmetric difference is nothing but A delta B, right? A delta B, and it is equivalent to what? It is equivalent to A minus B union B minus A, right? A elements are present only in A or only in B. So which part will be coming through Venn diagram? This part, right? This common area will not be coming. Okay, this common area will not be coming in A symmetric difference with B. A minus B element which are present only in A or only in B. Okay, so I hope this is clear to everyone. What is A symmetric difference with B, right? Now next. Next is what? If suppose this is A, right, this is A and this is what? U, okay, and I want to find out A complement, right? I want to find out what? A complement. So A complement is everything but A, right? A complement is everything but A. So the answer for this will be what? This, right? This will be what? Union minus A. Sorry, not union, universal set minus A. Everything but A. Everything but A. So everything outside of A from the universal set. Okay, I hope this is clear. What is the meaning of A complement, right? Okay, now let's say if I want to find out, this is A, right, and this is B, and I want to find out A union B complement, right? A union B complement. Okay, so I know what is A union B. A union B is this part, right? So A union B complement will be what? Everything but A union B. So the answer will be what? This. Right, this will be nothing but A union B complement, right? What I will do to find this? I will, from universal set, I will remove what? A union B, right? From universal set, I will remove what? A union B. Okay. Now let's say, okay, this is a universal set, and this is A, right? And this is B. And this is A and this is B. Now, I want to find out A intersection B complement, right? A intersection B complement. So I know what is A intersection B, this part. So A intersection B complement will be what? It will be everything but the common area, right? Everything but the common area, right? If you see, just this part is not coming, right? This part is not coming in that, right? Everything but the common area. Okay, so I hope this is clear to everyone. This is what about the Venn diagram of two sets, right? This is the Venn diagram of two sets. Now we'll be doing the Venn diagram of three sets. Okay, so for three sets we haven't seen anything yet. Now let's understand everything about three sets. Okay, so let's say this is A, this is B, right? And this is C, right? This is A, this is B, and this is C, right? And we want to find out what? A union B union C, right? A union B union C. So what will be this? Right, this will be what? A union B union C, correct? Okay, if I want to find out, suppose again for three sets, right? A, B and C, right? And if I want to find out A intersection B, A intersection B intersection C, right? Everything common between A, B and C. So it will be what? This particular part, right? This part is what? Common between A, B and C. Okay, I hope this is clear to everyone about A union B union C and then A union B intersection C, right? Next, so this is A, this is B, this is C, right? This is A, this is B, and this is C. And if I want to find out A intersection B, right? I want to find out A intersection B, right? Intersection A intersection B intersection C complement, right? C complement. Okay, A intersection B and C intersection C complement. C should not be there, but A and B should be there, right? So which part of it will be coming? This will be this part, right? In this part, A and B are present, but C is not present, right? In this part, A and B are present, but C is not present, right? Similarly, if I want to find out, similarly, this is A, this is B, and this is C, right? And if I want to find out A intersection B complement intersection C, right? A intersection B complement intersection C, then what will be happening? Right? We don't want B in this, so this part will be coming, right? This part is what? A intersection B complement intersection C. And third, let's say if I want to find out, again for three sets, right? A, B and C, right? And if I want to find out A dash intersection B intersection C, right? A dash intersection B intersection C. So what will be coming? B and C should be there, but A should not be present. So the answer will be this part. Right? The answer will be what? This particular thing. Okay? I hope this is clear to everyone. Right? Now we'll be doing for 2 sets. So let's say this is A, this is B, and this is C, right? This is A, this is B, and this is C. So I'll make a clone of it that, okay. Now see, if I want to find out A in complement intersection B complement intersection C, right? A complement intersection B complement intersection C. C should be there, but A and B should not be present, right? So which area will be coming? This area. Right, this is what A complement intersection B complement intersection C. Right, next, suppose if I want to find out A, B and C, right? So it is A complement intersection B intersection C complement, right? A complement intersection B intersection C complement. So which area will be coming? This area. Right? This is the part which will be coming for A complement intersection B intersection C complement. Right? And at last, if I want to find out this is A, this is B, and this is C. Right? A, B and C. And if I want to find out what? A intersection B complement intersection C complement, right? So what will be coming? It will be this area. Right? It will be this particular area. Alright? I hope this is clear for a complement. Right? Then all the areas are covered, I guess. Right? And if I want to find out, let's say, A union B union C complement, right? So for that, what will I do? This is A, this is B, and this is C, right? So everything but A, B, or C. So what will be coming in this? In that, it will be coming right, everything but A, B or C. Okay, I hope this is clear for A union B union C complement, right? So this is all about the Venn diagram. We have covered all the possible areas in this, right, and all the possible cases in this, right? There is a few more we can practice here. What are that? Let's say if they are asking us A union B, right, intersection C complement, right? A union B intersection C complement. So what I can do? This is A, this is B, right, and this is C, right? A union B intersection C complement. So what I can do in this? I need to find A union B but not C, right? A union B but not C. So which area will be coming in that? This particular area, right? This will be what? A union B intersection C complement, right? Intersection C complement. All right. I hope this is clear to everyone. Then suppose if I want to find out this is A, this is B, and this is C, right? And if I want to find out A complement, right, intersection B union C, right? A complement intersection B union C. So that will be what? This area, right? This will be A complement union B intersection C, right? And by same logic, if I want to find out A union C intersection B complement, right? So what I'll do, this is A, this is B, and this is C, right? So what it will be coming? They want A and C, right? So this will be this part, right? This will be A union C intersection B complement, right? There is nothing common between A union C and B complement. Understood? Okay, I hope this is clear for everyone. So this is all about Venn diagram. Let's see if we can practice few questions for it, right? Give me a minute. Let's practice few examples on this, right? Example. So we need to from Venn diagram, right? From Venn diagram, we need to show that A minus B, right? A minus B is equal to A intersection B, A intersection B complement, right? A minus B is equal to what? A intersection B complement. So what I will do, I will make a diagram. We already know what is A minus B, right? A minus B is what? This part. This is what? A minus B. And what they are saying? A intersection B complement, right? So, A intersection B complement, if I see, right? This part was what? A, right? This part was A, but we don't need, we want B complement. So, again this area will be coming, right? The same area will be coming. So, that is why we will say it is A intersection B complement, right? So, both of these areas are same. Understood? So, that is how we can prove it. Understood? Now, we'll be practicing, I guess, some questions from your book only. Okay. So, let's come to worksheet number. Let's come to worksheet number 16. Okay. Worksheet number 16. And from there, let's practice few of the questions, okay, in the class only, since we have some time left, and then we will be giving some of the homework from the worksheet, okay. So let's practice questions. Okay, first question, right? What it is saying, we need to identify, this is, suppose this is A, this is B, and this is C, right? This is A, B, and C, and they have marked the area, right? They have marked this area, right? Just a minute. Okay, so we want to find out this area. Let's say we want to find out this area. This is not the question. It is a similar question there in your worksheet, right? But this is the question, similar question is there in your worksheet. We are not exactly doing the question from the worksheet. So what could be this area now, right? What will be this area? Now see, this complete thing is what? This complete thing is A, right? This complete thing, this means, if I want to write down this part, right? This is nothing but A, so definitely A is coming, right? Definitely A is coming, okay. And if I want to, if I see what will be this area, this area is nothing but B intersection C, right? If forget about A right now, this will be what? B intersection C, right? So what have we done? We have taken union of A, and we have taken a union of A with B and intersection C, right? What have we done? We have taken union of A with B intersection C, correct? Okay, I hope this is clear to everyone. Now, same type of question I will give you here, that this is A, this is B, and they are asking, this is C, right? This is A, this is B, and this is C. And what they are asking? They are asking about this area. Right? They are asking about this area. So what will be this area now? Think of it similar to this way, right? It will be what? It will be A intersection C, right? Union B, right? It will be A intersection C union B, right? I hope I am clear with this, right? In your book also they have given the third type of area, which is C part. So you can see that from the question, right? So we have practiced both the type of question. In your book they have given this area, right? So that answer we'll discuss it tomorrow. That's a homework for tomorrow, right? This is the first question. All right, let's do the next one. Second one. Okay, suppose this is two figures, right? And we need to find out what is this area, right? Again, it is A, this is B, and this is C, right? So we need to find out what is this area, right? What is this area? So how will I find out? This is B and this is C, right? So what is this area? See, this particular part is nothing but A intersection B, right? And this particular part is nothing but B intersection C, right? This is nothing but B intersection C. So can I say these two areas are nothing but A intersection B union B intersection C, right? This is nothing but A intersection B union B intersection C, right? So yes, now what I can do, I can take, see, we can also write in this way also, that it is A union C, right, intersection B, right? A union C intersection B, right? So if I first find out A union C, suppose this is A, this is B, and this is C, right? If I find out here A union C, right? So in A union C, all this thing part will be coming, right? Everything, this part will be coming, but then we need to find out the intersection with B only, right? So out of this area, which is the common area with B, right? This part is common with B, right? So we can say that it is nothing but A union C intersection B, right? A union C intersection B. Okay, I hope this is clear to everyone. Okay, let's discuss the another question. So let's say there are three sets, right? This is A, this is B, and this is C. What I need to find out? I need to find out this value, right? Think of it. What will be this value, right? In terms of set, think of this.
अभी पढ़ा दूंगा ना तो कल क्या पढ़ाऊंगा.
Okay, so what will be this area, right? So this is what the B and C are completely not present in this, right? B and C are completely not present in this. So what I can say, this will be A, right? A intersection B complement, right? Union C complement, right? B complement, or I can say that, oops. A intersection right? A intersection. What is this? This is B union C, right? This is B union C. So I can say A intersection B union C complement, right? This is one way of writing this question. A intersection B union C complement. The other way of writing the same question is what? A intersection B complement intersection C complement, right? A intersection B complement intersection C complement. Now how it is possible? Let's understand. So what is B complement? If I want to write down B complement, right? So this will be B complement, right? This will be what? B complement. If I want to write down C complement, right? C complement will be this. Right? So if you see what is common between this green and violet color, this area, right? But it is also an intersection with A. So that is why A intersection B complement intersection C complement. And this can also be written as what? A intersection B union C complement, right? A intersection B union C complement. So can I say that from here that B union C complement, right, will be equal to B complement intersection C complement, right? Can I say from here that B union C complement is equal to what? B complement intersection C complement, right? How it will be coming? I'll show you. I'll take another slide for that. So let's say this is B, right? And this is C. Right now we are not bringing A in the picture. Let's say this is B and this is C, right? So if I want to find out B union C complement, right? So what will be that area? That will be this area. Right? That will be this area, right? And if I want to find out B complement intersection C complement. So first I will find out B complement, right? I'll make another diagram. This is B and this is C. So what will be B complement? B complement will be this area. Right? This is B complement. And if I want to find out C complement, right? C complement. What will be C complement? Right? This is what? C complement. And if I want to find out the intersection of these two parts, right? The intersection of these two parts, right? Can you see in this, right? This particular area. This particular area is common in both violet and yellow color. Right? This particular area is common between both yellow and violet color. That's why we can say that B union C complement, right? B union C complement is equal to what? B intersection B complement intersection C complement, right? This is one of the law of De Morgan's. We will be studying it tomorrow, or maybe day after tomorrow, or when we will be doing operations on set, right? So but from Venn diagram also you can understand that B union C complement is equal to B complement intersection C complement, right? If I want to write in terms of A and B, I can write A union B complement is equal to A complement intersection B complement, right? And also A intersection B complement is equal to A complement union B complement, right? A intersection B complement is equal to what? A complement union B complement. So if we prove this one, now let's prove this one, right? Let's prove this, how it is happening, right? Okay, so see, this is A, this is B, right? And if I want to find out A intersection B complement, right? A intersection B complement. So which area will be coming? This particular area. Right? Then what it is equal to? It is equal to A complement union B complement, right? A complement union B complement. So let's understand how it is coming. This is A, right? And this is what? B. Right? This is A and this is B. So if I want to find out A complement will be this area. Right? And what is B complement? B complement will be what? This particular area. Right? So what is the common area between pink and yellow color? What is the common area between pink and yellow color? Right? Not common, they are finding the union, right? So it will be which area? For union, you will get everything like this. Right? If you see, the middle area will not be coming, just the middle area. Right? Just the middle area is not coming in both of this one also and this one also. So from here, right, we can say that this thing is equal to this thing, right? So please remember these two things here. First is what? That A union B complement will be equal to A complement intersection B complement, and second thing, that A intersection B complement, right, is equal to A complement union B complement, right? These are two laws. We'll be doing it tomorrow also, De Morgan's law, but I have explained this thing through Venn diagram, right, in this one and this one. Okay, now let's revise the things what we have done, and then I'll give you the homework. Okay, so today we did about Venn diagram, right? Venn diagram, we saw what is A union B according to Venn diagram. Elements are present in A or B, right, or both A and B. Then what is A intersection B? A intersection B is nothing but elements which are common between A and B, right? Next, this is A minus B and this is B minus C, right? A minus B means what? Element which are present only in A and not in B, right? And B minus A is what? Element which are present only in B and not in A, right? So for that, what you have to do? You have to remove the common area from the particular set, right? The first set, correct? Next, symmetric difference. A symmetric difference B is what? A minus B union B minus A, right? So this is A minus B and this is B minus A. So we have to take the union of both of these sets, correct? Next, A complement. A complement is nothing but everything but A. So from universal set, what do? I subtract A here, right? Then A union B complement. A union B complement. A union B complement means what? We will remove A union B from the universal set. So what will be remaining? This particular area, right? And this is what? A intersection B complement, right? Everything but this middle area, right? Just everything but this middle area. Okay, then we saw for three sets, I guess, yes. For three sets, this is A union B union C, right? This is what? A intersection B intersection C. For three sets, this is A union B union C and this is A intersection B intersection C, right? Why? Because this, what it is saying, element which are present in either A or B or C, right? Element which are present in either A or B or C, right? So that's why all of the three area will be coming here, right? This, for this area, elements which are present in A only, right? This is the common area between A and B. This is the common area between A and C. This is the common area between B and C, correct? Now, next is what? We saw A intersection B intersection C complement, right? So we have taken first the intersection of A and B and then their interaction with C complement, right? We should not have C, so that's why we have taken this area, right? By similar logic, what is this? This is A intersection B complement intersection C, right? So A intersection C will be this and this, right? This area, right? But we have to take B complement, that's why this area is coming, right? Then next, what is this? This is A intersection B intersection A complement intersection B intersection C, right? So what is B intersection C? This whole area, right? And in this the whole area, we have to take intersection with what? A complement, right? So we got this A. Then we saw A complement, right? A complement intersection B complement intersection C, right? So A complement and B complement means what? This A and B will not be coming, only C part is coming, right? Here also by same logic, A and C are not coming, only B part is coming, right? And here A intersection B complement intersection C complement is what? That B and C both will not be coming, only A part will be coming here, alright? Okay, understood? So now this thing, since we have learned De Morgan's law, this thing can also be written as A union B complement intersection C, right? Same logically, right? Same logically, I can say that this thing also will be equal to what? A union C complement intersection B, right? So in option, sometime if they have given in this way, you have to identify this. This will be what? A union B intersections, sorry, this will be what? Right, this will be what? A intersection B union C complement, right? A intersection B union C complement, okay? I hope this is clear to everyone. And this is what? A union B union C complement, everything but A union B union C, right? So from universal set, I will subtract A union B union C, right? Then this is again from De Morgan's law, we have seen this, right? So this is it, okay? Now I'll be giving you homework for today, worksheet number 16, right? So today's homework is what? Similar questions I have made and done in the class, so you have to do it, worksheet number 16. Worksheet 16, right? It is on page number 77 and 78, right? Last, I think there are 3 more worksheets remaining, okay? 77 and 78, there are 13 questions, right? All 13 questions. They are very simple, think of it, and then we'll be discussing this tomorrow, right? All 13 questions, alright? So we'll end the lecture here. Now, after this, I guess there are 3 more worksheets remaining, 19, yes, right? So three more worksheet, and we'll be discussing the theory based on it, right? Alright, thank you everyone, see you tomorrow.